Here's the little mandrel that I made to turn these with. I cut these notches in here because when I turned the first one, I couldn't get it off of there, so I had to pry it from the back. But other than that, it doesn't really need those notches. I turned this for as close a fit as I could get on this bushing without having it so tight that I couldn't get it on and off of there. But there's only a 2 or 3 10,000ths clearance between the bore of that bushing and this diameter, so it would run as true as possible. There's a radius on one side of these bushings, and I'm putting it up towards this because the turning tool left a little bit of a radius here, and so that matches up nicely like that. And this is about 50 thousandths shorter than the bushing's length, so the washer will clamp it between these faces on here. And the maximum RPM that's this big machine can turn is 1600 RPM, so that's what I'm letting it turn for this hard turning. It's maybe a little bit too slow, but it seems to be doing all right. Let's see if I can explain what I'm going to do with these bushings here and why I had to turn them down. This is the what I call the drill plate for my drill fixture on the parts that I'm working on. And when I drilled this setup piece, which is aluminum, the holes were oversized, and I didn't really have this trouble the first time I've done this on the other part I did it on. But I don't know, there's something going on here. When I actually made this piece, well here's the ring gauge that I set this bore gauge to, and it's a 7/16 diameter. And if you can see that, yeah, that looks good. See, that's zeroed on 7/16 or 0.4375 on the gauge. And when I bored these this drill plate thing, the top of these holes are still good to that size, but as you go down to the other side of the same hole here, now it's oversized. And I'm not sure if the aluminum caused this or not, and if this will happen in the titanium, because on the other part that I did, I don't even believe I did an aluminum setup part. I did this whole thing and I just drilled it and it was on size. But now, because this isn't hardened here, and maybe it not being hardened and whatever that happens, I don't know. I don't know exactly what's happening here, but now I either got to remake this thing, which I could do, but then it would still be unhardened. If I heat treated it, then I'd have to bore these holes in the hardened state, and that'd be kind of a hassle. So I got these drill bushings, and I was going to just press these in here, but the OD was in such a size that they wouldn't fit next to each other, and so I had to turn them down, and that's what you just saw me turning these down, so that now I can bore this plate and fit these beside each other and have a hardened surface for the drill to run on, to see if this, although like I say before, I didn't have this trouble in the part I did like this before. But anyway, I can't afford to have anything go wrong with this. The parts, the setup piece, I wasn't too concerned about. You know, I was just setting up the program and making sure everything worked with the program, and that's a whole nother story in itself, because I was starting with a new software interface, this Esprit TNG, that I had to learn how to do and everything, and get the cycles going the way I wanted it. Although I really liked the software, it was a little bit of a learning curve for me. It's more or less the same as Esprit, but the interface itself is different, and so I had to learn basically the menuing and where to find, you know, the settings I wanted to do. But in this case, I can't afford to have anything screw up on these parts, because that part already has a lot of work in it and expensive material. They're probably worth, I don't know, $15,000-$20,000 at this point, each one of these parts, and this would scrap the part if it didn't do this correctly. So I'm going to bush out this drill guide thing, and then I found a piece of titanium in the shop here that's of the same type of titanium, and I'm going to actually mount each one of these drill plates, the one for the small drill, and to drill those holes first, and then mount this one on there and simulate the whole operation on this piece of scrap material to make sure that I'm not drilling oversized. If in an event I can't get this to work, what I'll have to do is actually then I'll have to make a new drill guide thing here. The small drill seems to be doing all right. I don't think I got a problem with it, and the size is not critical on it as far as plus or minus 1/1000 of an inch or 32 finish or anything. It just got to be a hole that intersects a hole further in the part. But this particular hole, the finish was really good, but it went oversized, out of tolerance. And the drill is a .4375 like this gauge, and the actual dimension on the hole is .438 plus or minus 1/1000, so it could go up to .439 and still be in tolerance. But they went over that, and actually they got bigger down in there as it went in, and I don't know if the drill was wobbling around or something. I'm not sure, and I don't think it'll happen in the titanium, because in general these gun drills don't drill oversized in this titanium material, and maybe it was the aluminum, I'm not sure. So I have to test it on the actual material, and I got to be darn sure this is correct before I do it on the real part. So I'm going to test it here, and if I still can't get this to work, then what I got to do is grind a form tool and drill it undersized, and come in with a form tool that will also create the chamfer and the counterbore that's at the top of the hole. So that's the other solution, but I'd rather not have to do that if I don't have to. So earlier in the video you saw me hard turning, and this was the insert I used to do it with. So this is a Sumitomo insert, and there's the numbers. I don't know if you can see that. And this particular insert, I think they call this their mini tips, because see, this only that much of the insert there, like you can see, is the CBN material, and the rest of this is just a carbide insert. But this is sized to fit in a CNMG holder, and this is the tip that I actually turned all those bushings with, and you virtually can't see any wear at all on it. I can't even tell. Maybe I'll if I can, I'll take a photograph with a microscope or something, but I can't see any wear at all on that tool. Maybe there is and I can't see it without a microscope, but these things generally work pretty good at the times I've used them. So that was the insert, and I was running the roughing passes were 4,000 speed, and the finish cut was 2,000 speed per revolution, and I was just running the lathe wide open at 1,600 RPM, because that's as fast as this big machine will turn. So that's what this is all about, and now I have to set this up and bore some counter bores to fit these bushings in here and press them in, and set this up to try this out. This will actually be flipped over, because this is the way it's oriented in the actual operation, of course, because the drill is coming in this direction into the holes. And I have to first drill the 218 diameter hole deeper than this port goes. This port goes 1 inch deep, more or less 1 inch 10/1000ths, I think. And then I'm going to drill those drill with the gun drill again in the real material to see if that holds size. because I think it may be the aluminum that's causing me the problem here too. If that drill tends to push out on the aluminum, it might cut on the side of that gun drill where the flute is ground, and it generally doesn't do that in titanium. So that's where we're at right now with this. Okay, I jogged the machine away. I've just drilled the very first hole here only. We're going to change the drill plate to the bigger drill. See, I just drilled this hole. I shallowed this up in the program. I copied a little section of the program. I processed code, I should say, for a little section of the program, and I reduced the depth of the 218 thousandths drill to just a little beyond the port's depth. So up here, the port goes about 1 inch 10 thousandths deep from this face. I had to be careful to set my 0 point out here because I'm going to run the exact same program except for reducing the depth of the small drill so that I can really test it as it would be actually running, so to speak. So now we're going to put the this larger drill plate on. It's going to go this way like this, and we'll drill this first hole in it only, and I'll run. There's actually a regular gun drill and then a flat bottom gun drill. So I'll run. I think I'm going to put a brand new regular gun drill in just to run it in here, and then the flat bottom is going to be the same one that I ran before. And then I'm going to take this off and see where we end up with the hole size. Drill doesn't really look too bad, but I'm going to change it anyway just to start with something brand new. Okay, brand new factory grind. Touch it off. And I got to remember this isn't 0 up here, so I got to be careful. Move the drill back so we can check this. And take the plate off. See how we did on this hole here. Check our gauge. It's reading a couple of tenths different today. Okay, it's zeroed. Let's see how we did. Hopefully. Okay. Not too bad. It's not out of tolerance. It could go, this is 37 and a half, so 38. It could go up 1/1000th and a half on this gauge and still be in tolerance. So that looks pretty good. It feels a little bit, it's not terribly smooth in there. Finish is not too great, but we run the spot facing tool. I got that in this program. We'll see what we come up with there. Diameter's good on that. Finish looks good. It didn't chatter or anything, so that's working perfect, that tool. The gun drill could have left a little bit nicer finish. I might try to grind my own grind on the gun drill and see if that does better, because that factory grind sometimes is off a little bit. So I'm going to sharpen one up and try that. But it seems to have that's the bottom radius there. Okay, here's where we stand with this right now. I drilled more holes. I ground various drills, a couple different drills, and I'm not really happy with what I'm coming up with here, unfortunately. The last 3 holes I got pretty good. If I hold this, and they're kind of all right size wise. See, this is that hole, but their finish is kind of a little bit, I don't know, I'm not happy with the finish on them, and it's too close to not being right, if you know what I mean. It's kind of like if a little bit goes wrong, it's going to be off, and I can't afford that on this part. I don't know if you can see. Let me see if I can maybe get some light, I don't know, down. I don't know if you can see that. I mean, it's not bad. It's not that bad, but it's kind of just too close to screwing up. I'm thinking I'm gonna go with my second alternative was to drill these undersized, these 7/16 flat bottom holes, which is basically the same program. I just have to get different drills, and I have to rebush that one piece that I did earlier in this video for a smaller size. And then I've got to grind a form tool that similar to the form tool that I was forming this top counterbore and the chamfer with, but it'll go all the way down and form all the way to the bottom of the hole. And so I think I'll reduce the drill size to a 64th under 7/16, whatever that is, and I'll drill and flat bottom the hole, and then I'll come in with this form tool. So the program actually won't be any different, except that the form tool will feed further down in. Other than that, the program's the same, which is nice, but I'm not happy with the way this looks. And if I try this and something screws up, we've got a very expensive part and it's not worth the chance to take on it. So unfortunately, I got to go my second alternative, which I said earlier in the video I didn't really like, but it's the safer way to go. I just got to order some tools next week and get some carbide coming in to grind these form tools with, because I don't have long enough pieces. I need a 9/16 diameter, but I'm going to need a 10-inch long blank to grind the tool and be able to hold on to it and reach into the part here. You know, this almost worked, and I did it before one time, but I can feel, I mean, you can't tell watching the video, but I can feel the coarseness of the finish with this, with these die test indicators. I mean, you can feel really you know, finishes real good with these things. It's almost like a profilometer. You know, you go in there and you can feel it, because this type, the flat bottom type that doesn't have the big spherical end on it, so it can go to the bottom of a hole, has a very narrow measuring surface on it, and you can feel irregularities in the finish real well with this tool, and it kind of is bothering me here. When prints say a 32 finish on it and the inspector gets it, he usually likes to have it like a 16 to really pass, and this isn't that. I can feel it in there. I mean, it's all right, the size now, but, and I could polish it, but I don't really like to polish on stuff if I don't need to. So unfortunately, I got to go the other route. So that's going to be it on this video, and the upcoming videos I want to show the doing this whole end and the shaping or broaching of the key and everything, and the 3D, you know, 5-axis tool path. And I was hoping to get to that in this video, because I know I hadn't posted a video in about a little more than 3 weeks, and it was because I've been learning this software and trying to get this setup working. So hopefully that'll be in the next video, all of that more interesting stuff. This is just something the only reason I bring up this in this video at all is to show you that sometimes you go through this stuff, and on these, you know, elaborate, expensive parts, you can't take a chance and have something go wrong, or at least I'm not going to, because I don't want to pay for that part and the labor and everything that's gone into it up to this point. So got to go with my alternative plan here, unfortunately. So thanks for watching.